Good afternoon, everyone. This is Kenzie Pulsifer from the Institute for Catastrophic Loss Reduction. Welcome to our forecast webinar for the 2019 wildfire season. We are very happy to have with us today Richard Carr from the Canadian Forest Service here. Richard is a fire research analyst at the Canadian Forest Service and Natural Resources Canada. He provides fire weather processing for the Canadian Wildland Fire Information System and international projects. He also provides fire weather briefings to the Canadian Forest Service Fire Group, the Canadian Interagency Forest Fire Centre, to federal emergency response personnel, and helps provide seasonal forecasting of fire risk. Richard also represents NRCan-CFS in the CIFFC Forest and Fire Meteorology Working Group. In today's webinar, Richard will summarize the current conditions in Canada and provide a forecast for the 2019 wildfire season. Just before we get started, I'd like to let everyone know that you can ask questions at any time during the presentation by typing them into the Q&A box on your screen. And we will save all of the questions for after the presentation. And also, today's webinar is being recorded, and you will receive a follow-up email with a link to the recording, as well as a PDF version of the presentation slides. And now I will pass it over to Richard for his presentation.
All right, thanks, Kenzie, and pleasure to speak to everybody today. It actually feels good to do an old-fashioned presentation. We've had a pretty busy week with all sorts of media interviews, television, radio, and newspaper, and so on. So it's more of a relaxing day, just getting back into a good old presentation here. So I'm just going to carry on from my title slide and head on into the content. First of all, just take a brief look at the agenda here. I'll go over a bit of background information, take a bit of a look at last year's fire season. I'll summarize some of the current global and vis-a-vis climate drivers and Canadian conditions. Go over our forecast methodology and provide the 2019 forecast. And we do the forecast monthly beginning in March and going through the summer. So this will be the May 1st edition of the forecast. I'll start with the background information. And just before we get into the meat of everything else here, Environment and Climate Change Canada opened a climate services website this year. So there's just a couple of sample products from that. So we're looking at summer, June, July, August temperature and precipitation trends since the reference period of 1961 to 1990. So this would be the change from the reference period. Temperature on the left, precipitation on the right. You can see that there has been a greater degree of warming in southern BC and then up through the northern parts of the provinces, Nunavut, Northwest Territories, and northern Yukon. And while temperatures have increased a little bit in other years, they're not quite as great as the regions that I've named there. On the right, precipitation, we see a actual drying trend from southern BC, even from the coastal regions, up through the center part of the province and through central Alberta. Then it gets a little bit more mixed up in the prairies, and we see another drying trend since that period around James Bay in Ontario and Quebec, and a little bit in Nova Scotia. Of course, we go up to the north, and we see drier conditions in the lower Mackenzie Valley, up towards the Arctic Ocean, and including some of the islands. Wildland fire in Canada, we're looking at a number of fires, which is the blue line from 1980 up until the present time, so 2018 will be the last year reported. And the area burned is the red histogram. We had the biggest area burned in 1989, and 1994 and 1995 had second and third largest area burns, so a lot of very big fire years back then. But you'll notice that in between those, there was a lot of years where we burned very little area, so under 1 million hectares in quite a number of years there. Now, since about the early 2000s, we've probably seen a fairly steady increase in area burned. The totals aren't quite as big as some of the big years, but we have larger clusters of greater area burned. And just very few years, only 2009 showed the total under 1 million hectares. Now, if you look closely, you can probably see a a dotted line through the middle of that, and that's the linear trend of area burn. So it's showing a slight increase, but it is increasing. We don't have a similar trend line for the fires here, so can't really show for sure what that's doing, but just visually it looks like the number of fires may be coming down a little bit, and there could be various reasons for that. One of them is just the way that fires are reported. Certain agencies at certain times may have reported an unattended campfire as a wildfire, even though it didn't burn any forest. So, I don't know if they're still doing that the same way. People may and probably are becoming a bit more aware of fire danger and consequences of large fires. So there may be a change in the number of human-caused fires, but once again, I don't have numbers really to back that up for sure. We're still saying that approximately 50% are caused by lightning and the other 50% by humans. And numbers vary a little bit from that 50-50 split, and they vary in the region of the country as well, with more lightning fires up in the northwest part of the country. Just a few general points about the forecast. The maps are available on the Canadian Wildland Fire Information System, or the CWFIS website. The URL is there, or the North American Seasonal Forecast Assessment Outlook, and that includes data from Canada, the US, and Mexico, and the National Interagency Fire Center in Boise, Idaho, that hosts that particular report there. So it looks a little different on their site just because of the way it's presented, but basic information is still the same. So I'll get into what goes into the forecast a bit later on, but information within the CWFIS that may include data provided by provinces and territories, as well as Environment and Climate Change Canada, who actually runs climate models to predict conditions over the upcoming years. So we use output of temperature and precipitation from their climate models to help drive our forecast. For the North American Seasonal Assessment Outlook and for briefing notes that go to our ministers, we may use visual assessment of other climate model output as well. I'll talk about that a bit later in the presentation. Now, in the Canadian Wildland Fire Information System, the monthly and seasonal forecast link is found within that yellow ellipse, oval, whatever shape I drew there on the left-hand side. So we just go down that left-hand panel to the monthly and seasonal forecast. And once you're in there, you can click through the actual forecast map for each month from the current forecast on through the rest of the summer. Lots of other information to explore on the Canadian Wildland Fire Information System website. So we've got fire weather, fire behavior, fire locations, both by hotspot and by provincial data feed from active fires, and all sorts of other information on there. Now, within the fire weather index system, you go out to the forest and see that fire danger line, just like at the bottom left there. That's the result of 6 different indexes, all predicting different factors within the forest floor. We've got 3 field moisture codes along the top. On the right-hand side one, the drought code, or DC, make use of for a seasonal forecast. And that actually tracks the moisture in the deepest organic layer in the forest floor, the humic layer. So that red arrow points to there. And actual end result of that from the fire weather index, we reclassify that into fire danger, which appears on the signs. Then to actually statistically analyze that, we have to do a conversion, and that's the severity rating. So that's calculated daily. But for a seasonal forecast, we roll that into a monthly product to compare with historical normal. Climate ensemble data, the models that model output that we use from Environment and Climate Change Canada's climate forecast models, they're developed actually by the CCCCMA in Victoria, British Columbia. We use temperature and precipitation. We could also include wind in the future. And there's 2 models. The CM3 is the older version. CM4 is the newer version. Each one of those consists of what we call an ensemble, 10 different forecast members all trying to predict the same thing with slight differences either in physics or in the initial conditions. And they each run out for a 12-month period, although our forecasts don't go out for 12 months, we just go out to September. So that group of forecast models is known as CanSIPS, or the Canadian Seasonal to Interannual Prediction System. Now, we'll talk about ENSO and other influences, and those will be represented to a certain extent in the climate models as well. So the ENSO, or El Niño Southern Oscillation. El Niño refers specifically to the change in sea surface temperatures, and Southern Oscillation, a corresponding change in atmospheric pressure and trade wind features. There's a couple of blue dots there. The atmospheric pressure is it's the difference between Darwin, Australia, and Tahiti. So Tahiti is close to the center of the globe in the lower right-hand corner. So at the El Niño, which is depicted there, we've got warmer than average sea surface temperatures extending westward from the west coast of South America out to about the central Pacific. We get the opposite effect, the La Niña, that sea surface temperature profile changes, so you end up with colder water towards South America, warmer water in the western Pacific towards Australia and Indonesia. The ENSO events, of course, I'm sure most people are familiar with some of the effects of them. So create global effects, floods, droughts, depending where you are. Persistence is usually 9 to 12 months, but sometimes you get events that last for 2 years or even a bit longer than that. It's kind of an irregular occurrence, 2 to 7 years. Sometimes I'll get one that fades off a little bit and then you get a resurgence the next year. Sometimes there's a bit of a lull, and I think we tend to get the La Niña episodes lasting a bit longer than El Niño. So we can have an El Niño and then go through 3 or 4 years of La Niña or neutral conditions when conditions aren't met for either, and then back to an El Niño after that. Tend to develop in April through the June, so late spring, but they reach maximum strength the following winter usually. They do have the biggest influence in Canada in the west over the winter and the spring, and maybe a little bit less of an influence through the summer. Now we'll just take a look at the history of fire problems in ENSO Springs, and it's got both El Niño, which is red on the left-hand side, or La Niña, which is blue. So the biggest area burned in 1989 was actually La Niña year. We're coming off the fairly strong La Niña, I think, there. And what happens in the La Niña year is we tend to get dominated by Arctic air. And while it could be cold in the winter, it tends to moderate in the spring. But in either case, it's very dry. So we tend to have large areas with very dry air. And as these Arctic surface high pressure areas drift south, we tend to get a lot of wind around the edges of them. So definitely a recipe for fire problems when you have windy, dry air for sure. Second most area burned was actually the opposite. It was an El Niño year, 1995, and I had a fairly good El Niño. It's just a moderate strength there, and stronger one in 1997-98, and had some fairly big fires in the spring of 1998. The Chisholm, Alberta fire came off a fairly long La Niña period in 2001. I've got a few things highlighted in the summer here. Kelowna, BC, southern BC had a lot of fires in 2003. And of course, past couple of years, 2017 and 18, and it's probably slightly different influences at work in those. We'll talk about those a bit later. Slave Lake, Alberta actually happened in a La Niña episode, and the Fort McMurray Horse River fire in 2016, once again, are coming off a very strong El Niño. So the strong El Niños, they tend to have fairly dry, warm winters and warm, dry, windy springs. So 2 of the 3 weather elements are the same as the La Niña, the dryness and the wind. Just really the temperature is a bit warmer in the El Niño springs. currently, we've been in a fairly weak El Nino. Just started in late 2017. Our trade winds didn't really couple. They tend to blow from the northeast or the southeast towards the equator. Normally, with the El Nino, they tend to reverse. And that didn't really happen until February, so kind of a slowly developing El Nino that's not particularly strong. So I think, we don't have a strong weather influence from that this spring. It's not really strong enough to give us, good direction in the weather pattern. So I think it's been a little bit more mixed up than usual. Sunspots, which probably have a slight influence on temperature. We've been in kind of a weak period of sunspots over the past, probably 15 or 20 years, I suppose. We've gone through a bit of a wide minimum, close to probably 2007 or 8 to 2010. Following maximum was quite a bit weaker than the previous ones, and then we're back into a minimum now. So while it may cool temperatures slightly in a minimum, I think we've seen enough warming globally that we probably won't notice any consequence from the sunspot activity or the lack of sunspot activity. Pacific Decadal Oscillation. At the bottom is depictions of the warm phase on the left and the cold phase on the right. On warm phase, we tend to get warmer ocean water along through the Gulf of Alaska, down the coast of BC, and then off into the Pacific west of Mexico. When we're in the cold or negative phase, we tend to get that warm water replaced by cold water along the west coast. Now in about 2013 or 2014, we had a phase change, so we've gone from the cold phase to the warm phase. And since that change, we've had some very big fire years in Western Canada, Northwest Territories, Saskatchewan. We had the El Nino in 2016, which, if it wasn't for the Horse River fire, it would have been a fairly quiet year, but just that fire alone contributed 500,000 hectares or more to the area burned. So it all came out a bit below normal, but not as quiet as some of the historical years where we're under 1 million hectares burned annually in the country. Now we have a bit of a fading over the past few years of the Pacific Decadal Oscillation. So since 2016, we've just kind of had a fluctuation back and forth between plus or minus 1 value, so a bit weaker than over the past, I guess, the early part of that 2013 to 2015 period. North Atlantic Oscillation, this is maybe affecting people in Eastern Canada a bit more than the West when we get strong episodes. Once again, we've had a fairly strong positive episode over the past few years, and that's tapered off a little bit. When we get a positive or warm feature, it tends to bottle up the Arctic air a little bit farther north and allow warmer air to flow up the Atlantic coast through all the southern and eastern Ontario, Quebec, and the Atlantic provinces. We get a cold episode while we tend to get a lot of Arctic air descending through the prairies, spreading out across the US and right out to the Atlantic coast. And then on a shorter term, Madden-Julian Oscillation is it's a tropical convective oscillation, just like a low pressure area that rotates about the equator. It tends to circle the globe in 30 to 60 days. The average period is probably 40 or 45 days to get around. With an active signal, and that's outside that circle. If it's in the circle, it's very weak and probably doesn't have much influence on weather outside the tropics. Once you get out halfway between the circle and the outside of that box, then we've got a pretty good signal, and might increase the zonal winds, the west to east flow in the mid-latitudes, might help transport more moisture across the Pacific Ocean, and can probably affect the positioning and strength of subtropical high-pressure areas that help regulate the weather features moving through the mid-latitudes as well. We tend to get what we call cold phases for Western North America. It's in phase 7, which is just starting across the Pacific, or phases 2 and 3 across the Indian Ocean or continental areas around that probably Eastern Africa, India, maybe approaching Southeast Asia. we tend to get cooler, maybe more troughing episodes, maybe cooler, wetter weather to western North America. But then we have some of those phases where it tends to probably strengthen those subtropical highs to the west of North America and provide warmer, drier weather for a period as well. So we've got a good moderate to strong signal. You might see a fair amount of change just in day-to-day weather patterns from the MJO. All right, let's take a look at the 2018 fire season. National statistics first. The red line is the 10-year mean. The blue bars, blue histogram is 2018 data. So the number of fires is up in the upper left there. We started off the year with a fair amount of active burning in Manitoba and Ontario. That's translated a bit further eastwards as we get into the midsummer, Ontario and Quebec, and then that tapered off, and BC erupted from late in July through a lot of August, and then it started to taper off again in September. So the number of fires actually came out a little higher than average, about 120%, 122%. At the bottom right is the area burned. So once again, it started off fairly slowly. The red line is 10-year average, and blue histograms are the actual occurrence from 2018. So it ran a lot below normal until late in the season, and it never reached the normal, but came up pretty close with a lot of area burned in British Columbia again. So it came out at about 85% of the annual area burned. Just another way to look at the 2018 season. The pink arrows on the left-hand side there show provinces that had more fires than normal in 2018. So BC, Manitoba, Ontario, Quebec, New Brunswick, and Parks Canada, which of course are scattered all over the countryside. And one thing that was made a big difference in 2018 was the fact that the Northwest Territories had very little area burned. It's probably one of their lowest totals for some time. So that's the blue arrow pointing at the Northwest Territories on the left. We had a fairly good chunk in that region, Northwest Territories, northern Saskatchewan, and Alberta, that normally experiences a lot of fire. That area of the boreal forest is one of the most frequently burned areas in Canada, yet there was very little fire in 2018 through that region. Bottom right is the area burned by province. So BC, once again, I thought 2017 had a lot of area burned. Well, 2018 actually eclipsed that mark by a little bit too. So a lot of area burned in BC. The rest of the provinces and territories were not quite so dramatic. Northwest Territories, with their tiny area burned there, just barely shows up on the graph. Manitoba and Ontario had a bit more area burned than usual. I guess Ontario had a bigger portion of area burned than the normal. But by far, the biggest area burned was in British Columbia. Now, what we predicted in 2018, on the top there are the ENSO predictions from the International Research Institute at Columbia University in New York. Those aren't actual our predictions, but we certainly look at these a lot. They are the ENSO, the El Niño Southern Oscillation Index predictions, and once again from a whole variety of models. So each one of those lines represents a different model that you can see listed on the right-hand side. So the top clump of those are dynamic models, and the bottom are statistical models. The horizontal black lines are the thresholds to reach an El Niño or La Niña episode. So if that sea surface temperature anomaly in the Central Pacific is greater than 0.5 degree warmer for more than 3 months, then you're in an El Niño episode. If it's colder for more than 3 months by 0.5 degree, then we're in the La Niña episode. So in between those, we just call it neutral conditions. And the vertical bar, the black bar there on the upper left graph, is the July, August, September period there, so just centered on August. So, mid to late summer looked like it was very neutral. That was the mid-March plume. So if you look on the upper right-hand graph, that's the same forecast, but just made from June. And once again, the black vertical bar gives the July, August, September period. So you can see that the actual forecast increased the indexes from, I think, most models there. So instead of completely being in the neutral area, they were starting to probably show El Nino characteristics. At the bottom left-hand panel there, we've got the sea surface temperature anomalies for the Pacific Ocean. Well, you can see the Atlantic as well, but really focused on the Pacific. Inside that red oval, we're looking at, basically those ENSO regions, and towards the middle of that is where the actual values are measured in the overlap of the 3 and the 4 areas, which I don't have marked on there. But you can see a bit of yellow and orange in there indicating above average sea surface temperatures. We've got blue along the west coast of South America, which indicates colder than normal temperatures, and white is pretty close to normal. So there have been studies that have suggested that when you get those warmer than average temperature anomalies in the Central Pacific, colder water along South America and maybe colder water to the west towards Australia and Indonesia, you might have warmer, hotter summers in Western North America. So, well, this was kind of a weak episode of that Madoki variation. It's a Japanese word that means similar, but yet somehow different. We might have had kind of a Madoki variation of the El Nino. Now inside that green oval above that, that's the area that we look at for the Pacific Decadal Oscillation. I guess following the pattern roughly, but once again we had a patch of colder water just off the west coast of Oregon and California, warmer water to the south and north of that. So maybe in keeping with kind of a weak Pacific Decadal Oscillation. And we also had a fairly weak Madden-Julian Oscillation signal through a lot of 2018. So while the bottom right graph shows a brief, I guess, higher value where the line is red there, it comes out over the far western Pacific, Southeast Asia area, and then across the part of the western Pacific before diving into the circle again. We had these brief episodes of a strong signal, but a lot of time spent within that circle showing a weak signal. So that weak MJO, possibly a Madoki-ish ENSO, kind of a weak positive PDO, it might have helped contribute to probably warming along the west coast, especially, and hotter, drier conditions. Now, with our own forecast, at the top row is our May forecast. On the bottom one is the July run. So we show the June in the top one. Of course, we can't show June from a July forecast, so we've got that bottom left-hand panel just blank there. But on the June forecast from May, we lit up a lot of central, the eastern prairies and western Ontario. And the area with active fires within the yellow oval roughly, so it did a fairly good job looking at June activity from the May run. By the time we got into July, the fire activity had actually shifted a bit east, yet our forecast had shifted a bit west, so definitely missed it from the May period. And in August, we lit up a fairly large portion of the countryside with fire activity concentrated in BC. So that's on the top right-hand image there. So once again, we probably got too much of an area, but at least we included BC, which was quite active, of course. The bottom row from the July run, once again, we kind of missed it in July, and probably had a similar result to the May forecast run. And then on the right, we did have the August-September period in BC indicated correctly, but once again, a little too much area to the east of that. All right, and your 2019 seasonal prediction, starting conditions. First thing we do is assess the drought conditions, and we have to start from the previous fall. So we had a very similar pattern to the fall of 2017, a lot of fairly dry forest extending along the 60th parallel up into the Northwest Territories and Yukon, down through British Columbia, and then eastwards through the southern prairies. And this map was taken from October 1st, and after that date, we had a fairly rapid plunge into winter conditions through a lot of the central part of the country. So this map actually shows probably the greatest extent of high drought codes that we see in the fall of 2018. Well, the extreme values, and we can't determine that from this map, but the greatest category here in the red is a value of 425 or higher. Well, fall of 2017, we had a lot of British Columbia stations reporting well over 1,000. The values weren't quite as high in southern BC in the fall of 2018, but the area represented in that extreme category was a bit broader, bigger area affected by drought than in the fall of 2017. And now what we do with the drought code is we adjust that for winter precipitation and come up with spring starting values, and we'll talk about that a bit more in a minute. But first of all, once we got through winter, we had a very cold February in a lot of Canada, and I think it went down as probably in the top 5 coldest Februaries in a lot of the West. That was followed by a very rapid change in mid-March. So, we went from minus 30s or minus 40s in the first week up to record-setting warmth through a lot of Western Canada by the middle of the month. Here's a couple of temperature plots from the Canadian Wildfire Information System, just showing a couple of days apart. So the top one is from March 18th. The bottom one is from the 19th. The lighter green, we're showing noon temperatures in that plus 10 to 20 degree range. So on the 18th, we're seeing that right up to the Arctic coast, which was quite incredible. And a little bit more widespread on the following day. So we had a lot of rapid snow melt, and in fact in Yukon, the snow melted off probably 2 to 4 weeks earlier than normal in a lot of the territory. I don't have numbers from Northwest Territories, but there's probably some pretty rapid melting up there as well. Of course, we lost it through a lot of British Columbia and the prairies at the same time. Just all that text that you see is just a snip of a weather summary for the Northwest Territories issued by Environment and Climate Change Canada for these are records set on Tuesday, March 19th, and this went on for several days. We just highlighted some numbers in red. It might be a little hard to read unless you look pretty closely, but temperatures in the mid to high teens, except Yellowknife sitting right on the lake, which is still frozen at that time of year. Records weren't quite as dramatic, but still beating the old record by a few degrees. Norman Wells, high of 16.8 on the 19th, beat the world record of 4, so it beat it by almost 13 degrees, and the record started in 1943, so it was a pretty incredible warm spell. And so we saw similar occurrences, right through all of Western Canada during that period. I guess that was kind of followed by more of a normal April and kind of mixed up weather patterns heading into May as well. Still, you get that early snow melt, and it can set the stage for early fires, and I'll talk about that a little bit more later as well. Now, current drought code. Once again, I've just thrown in the October 2018, October 1st, 2018 map at the left. A patch through the east central BC through the center of the prairies out towards Hudson Bay, where it's a bit lower, was the result of fairly regular rainfall last summer. And normally you get a lot of area burned through that area, but with that regular rainfall, it kept the burned area down quite a bit through that region. What we've got here is a May 16th, 2019 drought code on the right. So when we adjust those values for the winter precipitation, it reduces it. In Eastern Canada, it tends to reduce it right down to the minimum value usually, since they get probably 200 millimeters of more of precipitation, enough to zero out that drought code in the spring. Something happens usually along the Pacific coast as well, with averaging 200 to 300 millimeters per month through a lot of that region. In the interior of BC, though, it stays fairly high, and we've got some fairly high starting drought codes there, up into Yukon, and once again along the 60th parallel, and northern Alberta and the Northwest Territories. And the southern prairies started out fairly dry as well. The drought code may not mean as much in the prairie or agriculture region, just because we don't have a same deep organic layer that we'd have in the forest. Still indicating dry area though. If we look at other ways to look at the dryness in the spring, we've got some maps from Agriculture and Agri-Food Canada. At the top right is a Canadian Drought Monitor that they issue once a month. It's usually posted probably by about the 10th or so of each month there. So we've got patches of yellow which indicate abnormally dry right from northern Yukon down through the southern part of the territory and along the 60th parallel, and then scattered throughout British Columbia and the southern prairies. And interspersed in that is some patches of the D1, the moderate drought, which would be the lighter orange color, and the severe drought, which would be the deeper orange color. So definitely some very dry conditions starting off the 2019 season. Map excuse me, the map at the left is the 6-month precipitation departure percent of average. So, you know, all of the orange or yellow or red indicates drier than average. Once we get into the green, it's wetter than average. So once again, it's pretty pervasive across the country. And, you know, the only areas that are really wet, of course, are the southern parts of Ontario, Quebec, and out into the Atlantic, where they've had flooding problems this spring. So north of that, though, it's quite dry. However, if you look at the bottom map on the right, that's the snow anomaly map from the Canadian Cryospheric Network. The red line gives the mean area where the mean snow depth at this time of year is 2 centimeters or greater. And I think that map was taken from the 13th of May, so it's a few days old, but not terribly old. So still just trace amounts of snow cover through the northernmost parts of the prairies in Ontario. See a little bit hanging below that red line in Quebec, so still kind of a slow snow melt through Quebec, Labrador area, and the blue indicates a fairly substantial snow depth, or snow anomaly actually in Labrador, so pretty slow to melt off through that region. Current sea surface temperatures. On this diagram here, we show those ENSO boxes. So the area where the index is actually measured is in the red box in the center, where it says 3.4. Once again, we've got fairly warm temperatures out in the central Pacific, and it's a little bit more scattered through the area towards South America. But generally, we've had warm water coming off the coast of South America through the winter and spring so far. So in keeping with probably a weak El Niño, maybe starting to taper off more to a neutral condition, but generally in those 3.4 boxes, still a good positive anomaly there. So still a good indication that the El Niño event is continuing. To the north of that, in that red oval, we've got the area that we look at for the Pacific Decadal Oscillation, and still kind of a mixed up pattern, maybe in keeping with kind of a weakish positive event, or maybe more of a neutral event, with definitely a lot of warm water in the Gulf of Alaska and off British Columbia, but tends to stay to cooler water off the coast of the States, and then warmer again off the west coast of Mexico. So I guess the warm water along the Pacific coast of North America there is maybe not as intense as you'd see during a strong PDO episode, but still a hint that it stays probably in that warm phase. All right, into the seasonal prediction for 2019, we'll just take a look at the climate models and the CMC, Canadian Meteorological Centre forecasts, where the models are run from. The ENSO forecast, again, from IRI, International Research Institute, continuing to just predict a kind of a weak to moderate, I guess, El Niño continuing throughout the year, and that looks like it may continue into next winter as well. We've got the pink arrow there that is pointing at the Canadian CanSIPS Ensemble, which is kind of buried in there, but probably tending to start out maybe towards the lower end of the collection of models here, and maybe rising a little bit in the fall. I must add that the early part of the spring is subject to what's known as a spring predictability barrier, and the ENSO forecasts tend to be inaccurate during spring predictions. The early predictions are, the next 2 or 3 months are fairly erratic, and look out to the next winter, it maybe tends to miss the peak events by a certain time. So once we get closer to summer, those forecasts become a little bit more accurate. another way of looking at the forecast here. That's probability of either an El Nino, La Nina, or neutral conditions. And red bars are give the probability of the El Nino forecast. So early in the spring, 90% we're still in the El Nino episode. It tends to taper off to closer to a 50-50 chance by the time we get into the autumn. Greater chance, I guess, of having neutral conditions through that period, and just a very small chance of getting into a La Nina through the late stages of 2019. Now, climate models are, we're doing our best with them given the science of the day, but probably takes a decade or so to make substantial improvements in them. And there's a lot that we don't understand about atmospheric and oceanic interactions. It is reflected sometimes in model uncertainty. We can have very different forecasts between months, and the top couple of maps show forecasts from through successive months. So the one on the top left is a temperature forecast from December showing expected warmer than normal conditions in the February, March, April period. On the right is the same forecast just done from the January run. That suddenly shows a big pocket of colder than normal temperatures predicted in Western Canada for that February, March, April period. So it started out very cold. March went from cold to warm, and then April was probably pretty normal. So yeah, you can probably have to take that with a grain of salt sometimes. It's probably tough to get a good prediction for a 3-month period, but you'll see that they're quite often influenced by the current conditions when the model run is actually initiated. On the bottom right here, we've got the May, June, July period, once again from March and April forecasts. So we've gone from prediction of very warm temperatures across the country to a lot of cooler than normal conditions from the April forecast, just holding warmer conditions along the Pacific Coast, Yukon, and up over Baffin Island, up into the high Arctic. Now, if we look at our current forecast, this is produced on April 30th here for the summer, June, July, August. So temperature prediction on the left is showing high temperatures through BC, Yukon, and parts of Western Territories and Alberta. Precipitation on the right, showing possibly higher amounts of precipitation through parts of the Southern Prairies, maybe northeastern BC. Precipitation is a lot harder to forecast, so the accuracy is maybe not quite as good as it is with the temperature. And I must add that the CM4, the newer climate model from Environment and Climate Change Canada, seems to have a much better temperature prediction than the older model does. So definitely an improvement, I think, in the new model. Precipitation is probably going to take, I think, many years to work out good forecasts for that. Maybe not showing quite the promise in better results as the CM3, but I haven't analyzed that myself, so I might let the climate model experts do a better job of presenting that type of material. Into the fall, from this viewpoint, they're suggesting that temperatures on the left will be warmer than normal right from the BC coast throughout most of the country, and definitely centered on the Pacific coast, though. Maybe a little bit more precipitation up through northwestern BC and Yukon as we get into late summer. Now, besides the Canadian models, we may make visual assessments of other models, and there's a selection of them here. At the top left is what we call the North American multi-model ensemble. So this is all the North American models combined into one output. So it's, I guess, basically like taking a mean of all the other models that you see on the second and third row of this page here. You say from this is temperature plots here. I guess this was the most recent run, which was done in May here, and we're looking at the July forecast. So a lot of the models are suggesting kind of a pool of probably cooler, cloudy or moisture conditions in the central part of North America. And some of that might touch on Canada, and in fact the Canadian models in the middle of that second row show a fairly good sized pool of cool air possible in July through a lot of central Canada, but they do keep warm temperatures on the coast and up in the northwest for sure. And if you look at the ensemble on the top left, well, the consensus shows fairly warm conditions across most of the country, and maybe just keeping cooler conditions confined to the very southern part of the prairies and on the west side. Of course, you look at precipitation as well, so this is just temperature just for 1 month, and the next month might look quite different again. The Climate Prediction Center in the US does maintain skill maps for all the models that they show here too, so this just shows a sample of some of the skill maps. The yellow areas are predicting, let's see, just have to keep these things straight here. Temperature anomaly on the top there, and precipitation on the bottom. So the top two maps in the upper right-hand corner are just showing the skill maps from the CM3 and CM4. So showing a little bit more yellow on the CM4 for the temperature plot, so we're getting a better prediction there. And if you look at the precipitation on the bottom, it's not quite as good, but the precipitation may be good in some years or in some areas, but it's a little harder to do, so probably more scattered results there. All right, into the 2019 seasonal prediction. Once again, just the seasonal forecast methodology. On the top left, we're assessing the drought conditions in the spring. We have to have a base period to compare our current predictions against them. Once a year, we do a 30-year average calculation. So this is all run through the Canadian Forest Fire Weather Index system. So we do that for each ensemble element from each of the CM3 and CM4 models. So we're actually doing 20 forecasts of the same thing. So we take that temperature and precipitation output from their models, calculate our fire weather index, calculate a daily severity rating, and then roll it up into a monthly value. And that's the end result of that, of course, is the maps that you see on the bottom left of this image here. We're comparing that anomaly. We're comparing the current monthly severity rating against the same period for that 30-year historical period. Now, with the other models that I've shown you, the North American multi-model ensemble, all the things that go into that, we may make a visual assessment and maybe extend or shrink our areas a bit based on those assessments, come out with a kind of a line or polygon plot that you see on the right. So that's the type of product that we send to the US to put into the North American seasonal forecast outlook assessment. And we'll send those out to our federal ministers as well through briefing notes. So it's a little bit easier to look at, simpler to interpret. So the actual predictions on the left, it's for May 2019. Showing a lot of blue, which indicates below normal potential for higher fire severity, so probably less fire activity through those areas. White is looking fairly normal. So I don't see any red or pink showing up in May. It's been kind of a mixed up month with a relatively quiet start to the fire season. On the right is June, and we're starting to see things starting to perk up in British Columbia and Yukon. And of course, with warm temperatures, snow melts fast. In the forest, we do get a fairly good snow depth. It'll probably take a period of time for that snow to melt, and any water that's soaked into the forest floor will take a bit of time to evaporate. So, if the spring precipitation is a bit below normal, then and temperatures are higher, we'll probably start to see an earlier increase in fire activity. So we're showing that in June here. I do note that area right around the southern coast, probably in the mountains just to the east of Vancouver area, is lit up as well above average. Throughout the rest of the country, pretty much just average conditions through June. There's a couple of spots in Saskatchewan that are showing below average, but once again, there's just a couple of stations that are indicating that, and the numbers may be actually very close to the threshold, so we might color that entire area fairly normal. Something that I want to keep stressing here is the fact that we are a fire-prone country. We have average 2.5 million hectares burned each year, probably 6,000 to 7,000 fires or more. You know, even in normal conditions, we tend to have a lot of fire, and we can still have some fairly serious fires in normal years or in areas that just show kind of a normal severity. Now, I would just kind of reiterate kind of a slower start to the year. We'll take a brief look at the CIFFC situation report. They've just redone their web page, so if you Google CIFFC, if you're not familiar with that, you'll find their web page, Canadian Interagency Forest Fire Center. It's located in Winnipeg. That's the group that, first of all, coordinates the movement of fire suppression resources, both crews and equipment, between provinces, and helps move them between different countries in Canada as well. We also oversee a lot of working groups that focus on different aspects of forest fire management. So on the web page, the little blue arrows point from the current national situation report. That's updated daily over the summer, so you can look at the very bottom of the report, you can look at the provincial totals of fire from the past 2 years and compare that with averages from various periods from 5 to 25 years. So, you know, if you looked at the recent report, you'd see that the number of fires is somewhat close to average. Up the top right, I've indicated 87%. When I looked at this, I think yesterday, so the 16th. Area burn, though, is very low for the time of year, sitting at 27%. So pretty slow year as far as area burn goes. So fires close to normal. A lot of those fairly small, easy to manage so far. There have been a few that are a little bit larger, maybe presenting a few more challenges, but those big fires have been in the minority so far this year. I'll get back to the actual forecast. Oh, maybe not quite yet. That's another way of looking at the current season on our own site, the Canadian Wildland Fire Information System. Once again, on that left-hand panel down there where the link to the seasonal forecast is, you'll see a link to the situation report. So we don't update this daily, it's a weekly product, but we do feature graphs by province showing number of fires, area burned, and there's a few more things. So that green star down there just shows where that link is on the left-hand side of the CWFIS page. All right, back to the forecast. So we're looking at July here. Both maps here for July, just we've got the automated plot on the left showing the shaded areas and our line diagram on the right. So what we've done on the right there is just join those areas together into one big areas. Once again, we're highlighting most of British Columbia and a portion of the Yukon, maybe not quite as far north as we saw in June, but still basically the same area. August and September, August on the left, once again, British Columbia is indicated, not much else, but once again, we could still get substantial fire activity in the rest of the country, but maybe not as prevalent or as intense in BC. On the right, that tends to shrink down maybe a bit further south and expand throughout the southern prairies. I've drawn the blue line on there. Anything above that roughly is maybe not subject to too much fire activity in the fall. Once again, into September, we tend to hold moisture a little bit better in the forest. The nights are longer, a little harder to evaporate moisture, so we tend to get a reduction in fire activity, even though the conditions may indicate it's more conducive to fire. Okay, I've just selected a few stations across the country, just showing the different aspects of the forecast, maybe temperature, maybe precipitation, maybe the cumulative severity rating. So we start out with the 2018 Comox BC run just for reference, and we'll compare that with the 2019 forecast. So 2018 temperature plots are on the left from the CM3 and CM4 models. CM3 on the top, CM4 on the bottom. generally showed an above normal trend in temperatures, or all above that black line, which is the historical mean. On the right, we can see the severity rating increase pretty much consistently throughout the summer. 2019 run, once again, we're seeing that trend on the left to above normal temperatures and corresponding increase in severity rating. By the way, the little green key map on the right gives the approximate location of the weather station. Move a bit north and look at Prince George, looking maybe a little bit above normal, maybe not quite as dramatic as Comox along the south coast. So, but of course, fire behavior can be a bit different out in the Prince George area, where the terrain is not quite as rugged, so maybe fires have a greater chance of becoming bigger out there. Fort Simpson, Northwest Territories, looking at temperature on the left again. CM4, the bottom model, tends to have a warm temperature bias, but with a greater accuracy in its prediction, it's probably a bit better of a model too. So I probably think that temperatures will continue to run a little bit above normal in Fort Simpson. Precipitation may be close to normal though, so we end up with a pretty normal looking severity rating on the right. It may be a bit high, so especially with the early snow melt up in that region, possibility for some fire activity, but maybe not quite as dramatic as we see a little further west. We're on Saskatchewan, pretty much near the center of the province. Once again, the CM4 with its higher temperature predictions are probably driving a slightly higher severity rating there, but if you combine the two, it probably comes out fairly close to normal. Moving up to the east coast, Halifax, maybe showing warmer temperatures. Probably see an increase in precipitation through the late summer, and we do have a slightly elevated severity rating, but it maybe not high enough to create too many additional problems for them. All right, so I'd just like to reiterate some caveats. Our forecasts depend on climate model limitations, and while there's work going on to improve them all the time, it is a fairly long-term process. The predictions may change substantially with each run. The early spring forecast coincide with the ENSO predictability barrier, so as you get closer to summer, we may see improvements in model performance there. Now we're looking at things on a monthly basis, and of course weather patterns don't just decide to change on the first of each month. It might be the second week or the third week, so I can have those pattern shifts partly through a month. So we predict a higher severity anomaly for a certain month. Well, half the month may be like that and half might not be. So, maybe there's a different way that we can depict the time, I guess, span for those trends where it's going to be above or below normal. And it's going to take a lot of thinking to do that, I think, but maybe a better way to present these forecasts sometime in the future. Normal conditions are based on slightly over 100 weather stations, and maybe we can improve that, get a bigger selection of locations, or use gridded data to help improve our baseline there and our predictions as well. When we estimate the snow melt, well, each month we run that drought code assessment. If the station still has snow on ground at the time, there's no FWI done until that snow actually melts off. So we try to estimate the snow melt date if snow cover is present, and that's based on just 30 years or more of historical data of snow melt at that particular location. So it doesn't consider forecast temperature. Another option, I guess, is to use snow melt from the actual climate model, since that is one potential output that we could tap into there. Possible improvements in our models, well, we could include wind speed in the calculations, and we've got part of the code built in there to do that. We just haven't clicked it on yet, so we'd have to go through a bit of a test phase just to make sure everything's working properly, but maybe one improvement we could do in the near future. I've mentioned using more stations or graded historical conditions on which to base our normals or the model output for the snow melt forecast. Of course, we want to validate what we're doing too, and We're not actually trying to predict the number of fires in any particular area. We're trying to look at the areas where weather conditions would be more conducive to fire starts. And you can get some really high indexes, but if there's nothing to start a fire, then you won't get much fire on the landscape. So when you have those hot, dry, windy conditions, we actually need some human activity that may start a fire, or we may need lightning that can start fires. And if people are careful and you get little lightning, then there's a little fire on the landscape. We probably want to look at both where the indexes are predicted as being high compared with what the actual indexes were, and also looking at the number of fires that actually occurred. So there's two ways to kind of look at the forecast there to see how it performed. We're working on that at the current time, and maybe by this time next year we'll have something to show for validation. And we're just using Canadian models right now. At some point we might be able to include forecast data from other climate models as well. So a few conclusions. Well, we had a very quick change from winter to spring in March. It was kind of followed by a mid-spring cool spell in late April, early May. Dry in the west and northern parts of the provinces over the past 6 months, and in some parts of the country that's ongoing. And immediate-term climatic drivers are rather weak, so it's kind of a weak El Niño, a weak PDO, and so on. We might get fluctuating weather patterns that may be a little bit hard to predict, or maybe subject to fairly rapid change. Current CanSIPS forecasts suggest ridging in the eastern Pacific that would give warmer temperatures along BC, Yukon area, possibly into western Alberta and the Northwest Territories as well. And just as I've gone over in the recent slides, watch for improvements in the coming years. So we're just a few things to go over again. That in a normal year we experience probably 6,000 to 7,000 fires, burn 2.5 million hectares per year. So we do have a lot of fire on the landscape in Canada in most years. So even when we're not predicting above normal conditions, we'll probably still experience a lot of fire. We can have serious interface fires in slow years, so that's where it burns from the forest or grasslands into some type of human development. So we can still have fire where our forecast indicates normal or below normal conditions. So as a result of that, we encourage everybody to check updates for our seasonal forecast in the first week of each month. There's places where people can monitor daily conditions on the provincial website or the Canadian Wildland Fire Information System. I've just thrown logos up all the provinces and territories down here. Kind of found it funny that Ontario didn't seem to have a picture on their web pages. It just said Government of Ontario. So I don't know if they've cut back so far that they can't afford a web page logo these days. Anyways, each of these provinces and territories has a wildland fire website. So if you just search for the province or territory name and wildfire, you'll probably come across it. Could put URLs to each of those on here, but it probably makes a fair amount of management as URLs change from time to time. So just left logos in place for now. So with that, I'll end my presentations and maybe turn it back over for any questions out there.
Thank you, Richard, so much for the presentation. As Richard mentioned, we do have some time for questions. So if you do have any questions, we invite you to use the Q&A box that should be either at the bottom or top of your screen. So yeah, please go ahead and ask any questions that you have. Richard, I think I'll start. And I'm just wondering, based on the wildfire forecast predictions for this year, is it possible to say which parts of Canada seem to be most vulnerable for the summer?
Yeah, we're certainly looking at the westernmost part of the country, the British Columbia, Yukon, and western Alberta and the territories. And it's quite dry up near the 60th parallel still. So yeah, so it's predominantly in the west.
And does that mean it's a similar looking year as last year, or not necessarily?
Well, from what the forecast map showed there, we're shading BC and Yukon, Western Territories, probably Western Alberta, westernmost Alberta, I think starting in June. So, it's looking at from this point like, things might start up a little earlier. We can't, we can't say for sure that you'd end up with the same results as the previous 2 years in BC. It depends on, a lot more than just the indexes. It depends on ignitions as well. If you can get a fairly high index, but regular rainfall, even if it's light, that might keep things in check a little bit. If the lightning events are different, then we can have a different outcome. If people behave differently, you might have a different outcome as well. So as I say, we don't predict the number of fires, but just where the conditions may lead to more fire.
Okay, thank you. And another is, how do these the forecast predictions, how do they get used to prepare the areas that do get noted as vulnerable? How does it prepare them for their potential risk, or how can they be used in that way? I probably don't have a good idea of how provinces and territories may use these. Some of the provinces and territories generally have their own meteorologists, fire weather meteorologists on staff. Some of those people may do their own seasonal predictions for the province, and they may use different methods than what we use here. So there's probably a variety of answers from the provincial territorial point of view. It's probably good awareness, I think, for some of the provinces and territories for sure. Other organizations like the Canadian Interagency Forest Fire Centre, may keep the results in mind just from their own preparedness planning. And there's probably other organizations out there as well that may consider this as well. But I don't think we've done a real good assessment yet of how everything is used by everybody. It's maybe another thing to be done in the future. Okay, great. So I will let everyone know. Is it okay, Richard, if people send you emails if they have further questions?
Yes, certainly.
Yeah.
That's I've got my email up there and phone number, and I actually have the right phone number. I noted earlier in the area phone number still on the last slide, so I had to change that in a hurry.
Okay, perfect. Okay, great. So if anybody does have any extra questions for Richard, please see his email noted on the PowerPoint. And I will just let everyone know that our next Friday forum will be on Friday, May 31st at 1 p.m. The topic will be modeling of future flood risk across Canada under climate change, and it will be presented by Dr. Slobodan Simonovic of Western University. And thank you again so much, Richard, for the presentation today.
All right, well, thank you, and thanks to the audience as well for listening in.
Thank you so much. Thanks, everyone.